Good afternoon. Welcome to lecture 27 on thermodynamics of materials. We are discussing this adiabatic flame temperature, right? One thing I want to add that suppose last day we considered that the flame temperature reaction is an adiabatic constant pressure process. Is an adiabatic constant pressure process. But what if the process is constant volume instead of constant pressure? Adiabatic retained. So, reconsider the last day's problem. Last day's AFT, AFT discussion in the light of constant volume and adiabatic condition rather than constant pressure and adiabatic. So what is the reaction? So reaction under study, I write study is what? You write the same reaction I am considering. What is that? Fuel is the CH4 is bound with oxygen, CH4 plus O2, it goes to CO2 plus 2H2O. These are all gases. So gas, you write oxygen gas, CO2 gas, 2H2O gas. Okay? So this is 3O, 3 by 2O2. This today I am writing it is constant adiabatic as before, adiabatic and constant volume. So what is the figure like? So corresponding figure. The figure is like this start. Remember, what is the starting point? Tell me. CH4 plus 2O2. A constant volume reactor. Constant volume, CH4 I am not. What are you looking? Okay, 2O2 and 3 by 2O2. Okay, 3 by 2O2. No, it is 2O2, no? It is 2O2. O2O2, 4O. I think this is 2O2, sorry. Why 3 by O2 unnecessarily? It's 2O2, okay? So this is this is taken what? This is adiabatic. Insulation means adiabatic. Insulated. That is adiabatic. What is the temperature? Starting temperature recall? Oh, let me write that. This is what temperature you overall, the overall reaction under study. The overall reaction under study is what? Tell me what temperature? 298 K. Okay. And this is what? 298 K. This is T flame. This was discussed last day. 298 K and T flame. Okay. What is the pressure? This together is 1 atmospheric pressure, and this is also leaving 1 atmospheric pressure. You can write this. 1 atmosphere. This is also. This was last day. Okay. Today you just pressure. I am actually omitting pressure has not. Pressure will actually same. 3 moles. Okay, will change. Okay. One you can write that 1 atmosphere. But this is not so important because this is ideal gas behavior. Pressure is not. But anyway, that's 1 atmosphere. Because 3 moles to 3 moles. Moles don't change. So volume fixed. So pressure will be fixed. Okay. But no, this pressure will be, I am sorry, this is, okay, this is what, no, this is not correct actually. This is, as I told you, okay. what I will tell you here, T flame 1 atmosphere, right here, 298 K for temperature, 298 K, 1 atmosphere, starting, 298 K, 1 atmosphere, I wrote there. And what is the state 2? State 1 goes to state 2. State 2 is what? Constant volume. Okay, see, it is a constant volume. So should we look like, should look like same, CO2 plus 2H2. CO2 plus 2H2. 298K is what? Then this hot temperature, T flame temperature. Pressure will be, pressure will be, is not 1 atmosphere, will be greater than 1 atmosphere. Why? Different reasons, okay? Because moles are same, constant cause, adiabatic. Adiabatic, okay? So you write again insulated. Adiabatic, okay? So what is this? State 2 or final state? Right? Initial state, state 1, final state. Right here, constant volume, adiabatic, constant volume, adiabatic. These are the status. So what is this pressure actually is not important. Why? Actually I tell you, because if we consider ideal gas behavior, pressure changes, okay, state properties like internal energy, enthalpy. Don't worry about this. Okay, why it will rise? Can you tell me quickly? Since I have started writing, that's why. Otherwise, I could have omitted pressure. Only temperature is the main thing. But since I have mentioned that 1 atmosphere pressure I enter and P flame. Okay, so check P atmosphere. So it is P atmosphere, P, which is greater than 1. What is the P atmosphere? What is the P atmosphere? Why pressure 1 greater than 1? I tell you, see, same number of moles should not change, constant volume. But what, there are different reasons. Why? Temperature has risen. Temperature rises, so pressure will rise. Okay, so even though this pressure actually, is enthalpy or internal energy does not change with pressure, or ideal gases are consider ideal gas behavior. Okay? But then you will maintain this. Now, how will you proceed here? How to approach here? So, what is the criterion? Right again, like last time. Delta. This time, what will you attack delta H? You attack delta H is Q. Is 0. Is correct. This time it will be wrong. Delta H is not Q in a constant volume system. In a constant volume system, delta H is not Q, delta U is Q. So you have to change this. So this time, otherwise okay, delta U, so this is delta U rather than delta H. So what is the reason? What is the reason? Constant volume. This is Q, constant volume, for constant volume. And why it is 0? For adiabatic. So what is the difference? Delta U is 0. So you will solve this problem. Okay. Delta U is again. See, delta U will be delta U1 plus delta U2. This is overall reaction. For reaction 1. For reaction, which is the overall reaction. This is it. So you break up and proceed. Okay, and break up. You break up. How will you break up? Again, tell me. This is one temperature to another temperature. You carry out, write the reaction, same temperature. Then that 298 to 298. Then this 298 to T flame. And also you can add pressure change. Pressure change factors will be 0, considering the ideal gas behavior of this participating species, because internal energy does not change with pressure only. So that's all. Anything. So don't worry about this. So temperature is So you proceed this way actually. Remember delta U. Breakup, similar breakup, okay? Breakup as yesterday. Okay? As yesterday. As last class. As in the last class. You do yourself. So instead of what you will proceed, instead of delta is delta U. Delta U data must be given. And instead of delta U, you know, delta U is what for temperature rise? What is the delta U? CBDT, NCBDT of the product. This will be from 298 to this. So forget pressure. Recall that. Note, pressure is not important. For very important for actual pressure is not important for the is not important since for ideal gas important for ideal gas for ideal gas behavior right. Recall U is not function of pressure. E is not function of pressure, or H is also is not function of, is function of temperature only. Is not function of pressure. Recall, please. As in the last case. So right, you try yourself. Okay. In that case, delta U data must be given instead of delta H. That is not your concern. The data will be given. Only here I have correctly said one temperature to another temperature in a constant volume to CBDT and CBDT. So this part you can do. So this actually I missed another part. Take up one problem. Next, consider the following problem. Next, take up one practice problem. Then I will take up assignment after this. I remember this one practice problem. This actually I intended to finish last day's class. Where I was. So, so what is Barakpur local is running well. Barakpur local interrupted. So how did you come first? Okay, unnecessarily. Interruption, you should have not come. Okay, Barakpur local, you should consult with this railways. So what's the problem, sir? So Barakpur local should run in time. Okay. So now take up one practice problem. What is this? This is problem. A certain quantity of liquid gold. You practice this. I wanted to finish this yesterday, but I could not. Liquid gold is what? Gold is, liquid gold is AU. Liquid gold AU is supercooled to 950 degree centigrade. It is actually 1223 Kelvin. You may check this. Tell me. Oh, really? You want to? What fraction? Liquid gold, a certain quantity of adiabatically content. Adiabatic is coming number of times. Isothermal adiabatic, it should be fully proficient, fully skilled adiabatic. Not only in case of ideal gas adiabatic process, reaction adiabatic. Apply the concept adiabatic. Apply the concept isothermal, not only for isothermal expansion of a gas, 1 mole of ideal gas. No, here, both. For reactive system, reaction system. Of adiabatically, a certain quantity of adiabatically a certain quantity of an adiabatic content, a certain quantity of an adiabatically content liquid gold is supercooled to what fraction of the gold spontaneously squeezes out. Spontaneously freezes out. This is a question. There's some data given. Okay, first of all, let us. This is gas scale problem. Okay, gas scale problem. Acha. Data given. Data, I tell you, some data is given. Melting point of gold. Well, melting point, M for melting. Huh? Melting point of gold, this is melting. Melting point. Gold is what? 1063 degree centigrade. You know this? How to do this? You know this? Kelvin, okay. Don't worry, don't worry. Huh? Remember how you get this? You know? Plus 273. Plus 273, you know? 1063 plus 273 is 1366 Kelvin. Okay. This you can give in bracket, okay? Very good. And what? Cp of gold liquid 29.6 joule per mole, joule per Kelvin maybe first, then mole. Cp unit. And what else? Enthalpy of melting. Enthalpy of melting of gold. What is this? Write nicely. This is enthalpy molar. Molar means for 1 mole. Okay, 1 mole naturally given. Then any number of moles you can find out. Molar enthalpy of melting of gold is what? 12,760 joule. This is your problem. This is your problem. Okay. Let me check that your data actually should not be wrong. Is correct actually. Everything is correct. 29.3. This is 29.3. Others also. So I'll actually solve this problem this side. Actually no one is here. This side. Can I remove this? This is over. Huh? This is okay. Remove this. So make some room. So reconsider the last day. You don't have to reconsider anymore. Let us solve this problem. Then this will help you solve some assignment problem also. Namely what? Okay, 3, 4, etc. Let's start. So overall process. The overall process. Always the overall. The overall process. Is what? I'm writing. Okay, no. Sorry. Before this, let n moles of liquid be taken. Let n moles, a certain quantity, n moles. Let n moles of liquid gold be taken. And let X fraction of the gold let X be the fraction, let X be the fraction of the gold that freezes out. These are taken. Now I'm writing the overall process. Follow this. The overall process, or this is a reaction. Phase transfer is a reaction. I can write reaction also. The overall process. I was about to something. By the way, quickly going back, molar enthalpy of melting. Enthalpy of melting. What's the other name? Enthalpy of melting. Other name I taught you in high school. Actually, that you are more familiar. Latent heat. This is latent heat of fusion. Melting means fusion. Freezing is solidification. Freezing is the opposite. Solid to liquid is melting. And that is fusion. And liquid to solid is freezing. Solidification. Okay. So this is also latent heat. I told you other day. You have forgotten. This is the latent heat. That is the latent heat of fusion. Careful. Always correlate. What you know new and what you know now. Okay. Latent heat of fusion. Latent heat of melting. Fusion means melting. Careful, okay? Fusion means melting. the overall process, or I should say reaction also. I consider phase transformation as reaction. Reaction. Quickly, I don't have much time. N moles. Follow me. What I am doing? A simple-minded approach. Complex mind will not be able to solve. Simple. Like high school, primary, or maybe secondary student. Simple. N moles of gold liquid taking what temperature? Okay, guess? Super cool. Why super cool? Unless you super cool, then it will not freeze. Okay, at the freezing point, at the melting point, it will not freeze. Should be below, kept below. So that's why we have. At what is the melting point you have seen? What is that? 1336. And what is this? What temperature? 1223. Obviously below. That's why it will freeze out spontaneously. So what temperature I have taken? Tell me. 1223 the super cool temperature. I have taken. Then this goes to what? What? This goes to what? Again I am writing, for condensed phases, I actually use, I normally, as I told you, constant pressure, only condensed phase, okay, so I am writing. Coming to this, what is this? What it has been? Some fraction has been solidified. Let the X fraction of the N means Xn gold has been solidified. And what? The remaining one? N into 1 minus X. Gold liquid, the remaining. What is the temperature? Tell me, what is the temperature? This is follow. You start freezing. The moment it freezes, what happens, heat is rejected. It is released. For melting, what you need? Heat is to be given, to be absorbed, it to be input, and here it will be released, output. So that heat, since it is adiabatic system again, heat comes out. Since adiabatic, heat is not transmitted to the outside surrounding, so heat will heat up the temperature of the system. What is the temperature? I started 1223, so it will rise, 1250, 1300, 1320, and a time it will be 1336. The 1336 is the melting point, freezing point. So then once it hit 1336, it will stop. There is no more freezing. Okay. So when they stops, what fraction will after this X fraction, it will attain that critical temperature, the freezing temperature, melting temperature, same thing. Okay, is 1336. Can I write 13? I am always do this problem. Okay, 1336 Kelvin. Okay, 13. Should I? Why I am not getting time actually? Should I write? Why? Should I write this here? 1336 Kelvin. That's it. This you have to understand. Okay, and you write here what is the process? Write here better. Adiabatic, and what? Since condensed phase, we commonly consider it may be constant volume, but constant pressure. For condensed phase, volume actually changes are small. So constant pressure, you may consider this process is a constant pressure process. So so it is constant pressure. Okay, I will sketch this problem. Let us sketch this reaction, sketch this process. Happy? I can do, then you will be very happy. What is the sketch? Start. Sir, adiabatically content. Very nice, sir. Adiabatic. What I have taken? N moles, sir, gold liquid, sir. What temperature starting, sir? 1223 Kelvin. Actually, I am sketching these lines. So what is this? Adiabatic, sir. State 1. Initial state, it goes to what? Goes to, tell me, state 2, still adiabatic. Okay, again, insulated, adiabatic. And you write adiabatic here plus constant pressure. Condensed phase, actually, constant pressure very helpful, constant pressure. Okay, volume may be, okay, and moreover, volume change also constant. If volume changes, it is very so small. It is constant volume either. So does not make much difference. But constant pressure you can consider say atmospheric pressure. Okay. So this is actually say 1 atmosphere. Yeah. This is converted pressure. So constant pressure. So say subjected to what is this side? Tell me this Xn fraction. Xn gold what? Solid plus and this N into N times 1 minus X gold. liquid unchanged. It has not been fully converted. It has not been fully converted into solid because let's stop. What fraction? What fraction? That we wonder. What fraction? Maybe 100% then we consider this is 0. When x is 1, fraction means less than 1. Fraction. So if the fraction is 1, then obviously this will be 0. But let us check. Let us see what it is. What fraction? Understand? So some unchanged. What temperature? Just write the melting point itself, freezing point, okay, rise. Why the temperature rise? I have explained, okay, because this exothermic process, okay, very good. One thing, now solve. Now the solution here, let us start this place. This is not the good place to solve the problem. How you solve the problem? Acha, I have sketched this, so it is unnecessary to have this problem here, na? This is sketched there. So I can remove this, no? Or data maybe, but I remember this data. Acha, anyway, I will remove this part. Need some space, no? Melting point is already, this is, okay. Another thing, right, for actually perfectness, okay, for purity, enthalpy of melting of gold at 1360 Kelvin, okay, at the melting point. Molar enthalpy of melting of gold at 13, because this is a function of temperature through Kirchhoff equation. Similarly, phase transformation, okay. Also, this is also any enthalpy of melting is an enthalpy change, like chemical reaction, one temperature to another temperature. So temperature should be specified 1336 Kelvin, the melting point. It will be complete. Oh, you write here. You can write here. Then you don't have to write in language. Enthalpy of melting at 1336 Kelvin. So these are the data. This top data may be removed, but let me say solution. And before I start solution, okay, solution I have already started. Solution, right? Solution here. Continue rather. Continue. Okay. I'm saying break up. I'm breaking up. One thing I may forget. Very important concept. And you answer this. Okay. That is, this is something. Okay, some additional discussion. By the way, some discussion by additional discussion related. Some additional discussion here. Tell me, I am asking questions. So water, you know what is the freezing point? Water, 0 degree centigrade. 0 degree centigrade, which is 273 Kelvin. I asked based on this. What is the melting point of water is 0 degree centigrade. What is the freezing point of Barakpur? What is the freezing point of water then? You have no idea. Melting point is 0 degree, everyone agree. What is the freezing point of water? 0. Melting point of water, okay, 0, okay. So backward. So this is the freezing point as well, melting point or freezing point, okay. So this is, now I'm asking, answer this. Follow me, okay. I've taken, what I've taken? Liquid water. So don't worry, liquid water. Means the water, liquid water. What temperature? 273 Kelvin in a container. Will you stay there? Think, I am giving 3 cases. Think while I give the other 2. Will it be equilibrium or it will change, etc. What will happen to this gentleman called liquid water? Means water. Oh, sorry, liquid H2O means water. Is this? Then another similar, solid water means ice. As you know, solid water, which is so liquid water. This is water. This is ice. This is ice. The same temperature of 273 Kelvin again. Sorry. And then third is a mixture of liquid and solid. Okay? The liquid, H2O liquid plus H2O solid. Again, what is the temperature? 273 Kelvin. Tell me, these 3 situations, what will happen? Will it remain there or move? Will it remain there or move? Will it remain there or change? Move this side or this side, or melting or freezing? Question. Is it stable? Is it stable? No, water is not. and 270 it is not stable. Then what it will be? Ice. Why partiality? Why it is ice? Why not in liquid? A part ice, part water. Then why not full? 270 I maintain. I maintain 270. That is my job. So stable. Wrong. So stable. Okay. This is the equilibrium. Okay. Stays there. Okay. So stable. Stable state. Stable state. This is the answer. And you write call this equilibrium state. Alone. Equilibrium means does not have to be liquid solid. Alone. Equilibrium. No problem. Follow. This will be useful in your phase diagram. Binary phase diagram in your. And this first line I am removing melting point of water. This I am getting sun. What is this? This is stable. This state, ice, will convert into liquid water, liquid H2O. Equally stable, sir. 0 degree centigrade, very good. Okay, so it is again stable. 0 degree centigrade, it can. So try to. If you have any confusion, now you actually correct it. And okay. So again stable and equilibrium state. Stable or equilibrium state. No one can change. What happens to the third one? Third one here, what will happen? These two are easy questions for you. These are high school questions. This was in fact mixed. What will happen? Unstable. A change who will change to where? Again stable. Again equilibrium. Both coexist, stable. Very happily stable. No confusion, stable. This is you have no confusion. They are together. Ice and that is the equilibrium. Two-phase equilibrium. So again same. So concept stable or equilibrium. You have to be careful about this. Careful about this. So that means this state is liquid, solid, coexisting at the melting point. No problems of that. That is what I expected. Correct? At a whole life. Whole life I tell you. So this table. So this discussion is okay. Can I remove this now? Okay. I remove this. Now start. I will soon remove this. Problem. Break up. See what I taught you? Any moment you see, I see temperature. Different temperature. Break up. Same temperature one step. Then temperature to final temperature. This is the second step. One is heating, and like this. Don't worry. It is not a chemical reaction. Oh, okay, maybe. Okay, let us see. Start. I am writing. So I am breaking up. What is that? N moles. Achha, here I am giving the breaking up. Follow me with me. N moles I am breaking. N breaking into Xn plus N into 1 minus n. I think no one will mind. Will you mind? This is very easy thing. Xn plus n times 1 minus x is n. Hello? No, it is not exactly n, close to n. Exactly n. Xn plus n times 1 minus x, is it exactly n? Exactly n. You're right. Exactly n, sir. No doubt. Because n, okay, happy. So I'm breaking. Follow what I'm trying to do. I'm writing what? Writing. Break up into this. I'm writing Xn, follow with me. Xn, left hand side, Xn gold, liquid 1223 key goes to Xn gold, what temperature? 1336 Kelvin. Xn gold 1336 Kelvin. Then what will happen to this gentleman? Taking to this 1336. What I am giving? Gold liquid. 1330 right here. And underneath 13. Temperature underneath. Subscript. Okay, subscript is good. Good place. So maybe step 1. Step 2. What I am saying doing, this gentleman will do what? Then it will go to solidification, go to freezing. So Xn gold liquid 1336 Kelvin goes to Xn gold. Now, let me remove now. Now it's the time to remove this discussion. Okay, some additional discussion over concept CP. This part is Xn gold solid. What temperature? 1336 Kelvin. You are all set. This is a phase transformation. Okay, gold liquid to gold solid chain. Third is what? What remains? You must get back to the overall. After addition of the breakup steps, get back to the overall. Then your breaking up is correct. So what remains? Xn I have taken. What remains? N into 1 minus x. N into 1 minus x. Gold liquid 1223 Kelvin goes to again N into 1 minus x. Gold liquid, obviously guess 1336 K. You just spare a minute to verify whether it is correct. The breakup is correct. Correct? Perhaps correct, na? Breakup is correct? Have you checked? So these two together is how much? N. Okay, you check this, yeah? It's okay though. And this cancel. So it remains there. So you are okay. But as if we are not satisfied further equivalent breakup for some reason, I want to cut down on the steps, 3-step breakup. This 3-step further equivalent breakup, equivalent breakup is what? Or simpler breakup, or say 2-step breakup. Okay? This is 3-step, 2-step, 3-step breakup. 2-step, this don't worry, this will do also, this will do. What is this? I am adding this to do mine. See, 1 and 3 you can easily add, na? Same, 1223, 1223 liquid, 1336 liquid. So you can add what you get, if you add this to what you get on the A. I am writing, this is the step A. Okay, step A. Sorry. A is what? A is what? Step A. This 1 and 2 add 1, this is 3, remember. 1 and 3 is what? N moles. N moles gold liquid 1223 Kelvin to again N moles gold liquid, right? Gold liquid 1336. 1 and 3 merged. 1 and 3 merged into A. Step 1 and step 3 merged into A. And B is as before. B is the other step. Xn gold liquid 1336 Kelvin goes to Xn gold solid. Gold solids are 1336 Kelvin. Okay, 1336 Kelvin, 1336 Kelvin. You can give Kelvin or just you write 1336, we understand, everyone understand. So this is the 2-step breakup. And what I'll do? What is the job? Right here, relation. Here write. That fizzles out, you write here. Problem to find, what is the job? To find X. This is the job. What fraction? X. Let us solve. What is, you consider, apply this, what is this? Condensed phases, right here. Condensed phase reactions, may be conveniently considered, always this, conveniently considered constant pressure process. A constant pressure process. I am giving constant pressure. I am writing here for this explanation. Constant pressure process, unless mentioned otherwise. Will you write this? Unless mentioned. Unless mentioned. I will not get stress. Unless mentioned otherwise. Means constant volume it is saying, then do that. Constant volume actually, you know, unless mentioned otherwise. Okay, if it is constant, giving constant volume, then apply constant volume. Okay, but no problem. But even constant volume changes are so small, it is effectively constant volume. Constant pressure is also effectively constant volume, but anyway, constant pressure you stick to. Then what is happening? Start. So I am writing. So I am solving this problem. This space will go down. Now, next. Give a double star from this point. Double star. Delta HA. What is delta HA? Tell me. Delta HA is what? What? Quickly see and quickly. This is which step? 1223, same stuff, gold liquid, to increasing temperature from 1223 to 1336. So it is heating under constant pressure. So it is what? Tell me. N Cp gold liquid dt, and the temperature being 1223 to 1336. Okay. Let me substitute. What is the Cp gold? Right here. Cp gold is what? How much? 29.3. Write that out. 29.3. What you are getting? N is the unknown. N times, write this. 29.3 times, this is Cp is giving as a constant. Okay, constant, no problem. And it is 113. This is delta H. Delta HB. Delta HB is what? Okay, B is what? How I am writing? This way I am writing. Don't write this way. The way I have written, you write that way. Delta HA. You do one thing. Do one thing. You give, this is better. Please, this is better. Delta HA. Then you will very easy. Delta HA, delta HB. Delta HB is take a look. What is happening? Sir, phase transformation. Phase was N mole, X mole, Xn moles. So Xn moles, and what is the molar value? 1276. So 12 part 2. Sorry. Molar means here it is written molar. You can write here also unit wise. Then everything is clear. Both sides clear. Okay. So Xn times 12760. I'll be very happy if anyone can edit this if required. I will do something. First you write that. First write nicely. What is the unit? Write. What is the unit? Remember, can you tell me what is the unit? Joule. Mass. So Cp unit to do this. Joule per Kelvin, and Kelvin cancel. Moles is the N moles. So Joule and Joule. Okay. Draw a barrier here. Draw a barrier. Now tell me, anyone can tell me what if I have made any mistake? Xn, what is it? Liquid to gold. What is given? Melting. Solid to liquid. Liquid to solid, solid liquid. So it should be negative of this. Thank you so much. Minus. Do you mind? So minus 12760 Xn joule. Happy? Now this is the time to remove all these things. I think you don't mind. This is the time to remove all these things. Okay. Where the road molar. Okay. Don't do it. Wherever written. Now one thing, please follow. What is the level of this reaction? Overall reaction. What is the level? আমি কাজটা হয়ে যাক কথা বলছি এখন একটা সময় তো
মানে আমি মেটালোগ্রাফিতে আছি, আপনি জাস্ট হয়ে গেলে একটা ফোন করে নেবেন।
ফোন করে দেবো আপনাকে।
আমাকে একটা
আমরা করে দিলে হবে তো?
স্যারের সঙ্গে এইমাত্র কথা হয়ে গেছে।
আমি যাবো এই ক্লাসের পর। আমার মনে আছে, আমি রেডি হয়ে আসছি। So what is you should always label. Otherwise, this is the overall reaction. Overall. So give a name to this. This is bad here. So here, 1. This 1 I wrote somewhere, no? I wrote somewhere. Figure also. Don't worry. 1. So now tell me. Now please follow me. This is the breakup. 1 is the overall. So tell me delta H1. Happy? See, delta H1, the overall reaction. Since there comes the overall reaction. Enthalpy change. Delta H for the overall reaction. Sorry. It comes with though, but I'll remove this. Delta H1 is what? Tell me the breakup. Delta H1 is broken into these two. Broken into this two is delta H. Nicely right. Actually, first of all, what is the delta H1 by the way? Step by step is what? Since it's a constant pressure process, must be Q. Must be adiabatic. Here, these two gentlemen doing havoc. Havoc means solving the problem. Your life is fulfilled. It is havoc. If it is okay, ordinary. Okay, so 0. You write what's the reason? This is actually QP. Delta H1 is QP is 0. Okay, right here. Constant pressure, right? Since constant pressure, since adiabatic. This is one step. So now, and delta H1 is what? Can you tell me? This is broken into these two. These three, then these two is delta H a state property. State property, no way, sir, no way, sir. Anyhow you go. Initial final is delta H a plus delta H B. Now this is 0 or delta H A is delta minus delta H B. What is that? Write that out. Write that out. Okay, I am very close to this though. Thank you. Delta H A, please tell me. Delta H A is what? Ajay, you are done. All right, tell me. Copy. N times 29.3 times 113, good boy, is minus delta HB. Delta is minus minus plus 12,760 sir, X sir, N sir. That's it. This is the place you will have some relief and you are happy. N cancel. Certain quantity, and what is the value of X? Shall I write here or here? Complete it. X is, if you do yourself, do you have calculator? Any of you have calculator? You can check this value. Because if you check, then I will be very happy. A good boy. 0.26. Answer. That is what? This in fraction 0.26. What else? What is common? 0.26 fraction. Amorto. What else you would like to? In which way? Which way you want to express that? So what fraction of the liquid gold? 0.26 fraction. Yes. 26%. Same. This up. Okay. Is up to you. That is 26%. Fraction is required. But the answer is 0.26 answer. Happy? So this actually I wanted to discuss to give you some idea. Okay. Okay. Very good. So remove. Now start. I'm removing this. This I remove. Next. Start. Assignment number 3. Right. Remove this. Next. Now take up assignment number 3 due today. Start with problem 1. Problem 1 and problem 2 very easy. Then I'll take up the problem 1 you have solved, I guess. Problem 1 you have solved. Answer I have given. Answer I have given. Remember, in the assignment problem I have given the answer. Have you not solved? Problem 1? Why not? Who asked you not to solve? Did anyone request you? Please don't solve. So then when you learn, this is the time you practice new problem. You will get new problem. Don't worry. These problems will not be asked in the exam. These problems will not be. Don't think you can you master this, okay, and memorize this, etc. Does not help. A brand new problem, no. They ask your seniors, brand new. So what you will do? Because you are out of practice. You have never practiced yourself. Yeah, only thing what the problem you go through this. What will happen? You only know this. What is written here? A new problem will be totally strange thing for you. You do not know how to react with that. This is the time because I took up a new one and I challenged it. So you are losing the time. Very bad. Okay, and many of you actually I don't dare to ask. Have you, Mirja? I'm discussing. You know what I'm discussing? Have you solved problem 1? And then you are smiling here. See. Oh, what a stupid thing. Have you anyone else tried? Problem 1, only you and you. 2. Problem 2, you know how easy it is. I do not know what you think as what's the use of solving. Teacher will solve. I will solve actually give you how to write this. Okay? That is a nice way to solve. Okay, but you do a rough way to solve this. So do some way. Very bad. Oh, I cannot imagine that this problem 1 he could not. Then what happens? Problem 3, 4, 5, 6. He will simply He will simply actually Okay, this actually will be totally upset and You'll faint. What I'm saying. You're seeing that problem. This is to say, go step by step. Why you are? So, shall I lecture on this? Problem one, okay. Problem is taking about this. I tell you what. Very bad, very bad, very bad, very bad. 50 grams of. Should I write this problem? 50 grams of. Actually, let me remove all this by this time. All remove, all. A clean board, all. All. 50 grams of liquid aluminum, okay, aluminum. No, this is not liquid, this is not mentioned, aluminum, okay, aluminum at temperature T, at the temperature T are placed in, this is high school problem, typical calorimetry. You know, the heat rejected is heat absorbed. There is some heat rejected is absorbed is possible when when there is no heat loss. You see wrote there. The heat that is given by one body, hotter body, heat given by and taken up by the colder body, assuming that exactly same. No heat loss. And that is adiabatic. So you already read adiabatic in high school also. So these adiabatic are placed in 100 grams. Do you have the assignment with you? Your own assignment? Yeah. Get a copy. I told you, make a good collection. You don't have this habit, no? Make a collection of these hard copies. Placed in 100 grams of water, which is adiabatically content. Quickly, let us write quickly. Content at 298 K. Happy? Follow this. Follow quickly. Find out the equation. Find out an equation. Relating the final temperature of the system. The final temperature of the system. T prime of the system. Of the system T prime with T. This you have to find. Good boy, Harsham given data given. What is a CP? Gold liquid 75.44 joule per mole Kelvin. And another gentleman, CP aluminum. Aluminum is phase is not given. Solid or liquid is not given. So let it be unknown. But CP aluminum as it should be 16.3 joule per K mole. Okay? Oh, that's mole Kelvin. Oh, Kelvin should be first, better. Mole. Quickly, solution. Here it will be done. So is it start? Is again adiabatic and cis condensed phase. See solid liquid condensed phase, constant pressure you may consider. Okay, unless mentioned. So start. Now before this, convert into moles. Since these are moles, 50 gram of aluminum is what? What is aluminum atomic weight is 27. 50 by 27 is actually, let me write this quickly, save time, 1.85 unnecessary moles. It's like a gram atom. I tell you what, gram atom. Atomic weight, mass by atomic weight is gram atom. Gram atom is gram mole for metal. Okay, material, aluminum. For aluminum, gram mole and gram atom. Okay. So gram, okay, gram mole. Mole means gram mole. That is, in this case, gram mole. Okay, in this case, gram atom as well. In this case, so I'm not writing here. That's gram mole. So then another, no, quickly, water is hot, how, 100 gram water is what? What is the, what I shall divide with? Let's, what shall I divide? 100 gram water to convert into mole. Let us see. 18. So do it. 18. Okay. 18. And then it will getting 1.55 mole. First of all, you complete this. Then you write overall. 5.55. Sorry. Thank you. Then you convert quickly. You do this. Let me write. So overall reaction. So the overall process. This is not reaction at all. There is no reaction, no fast transformation, no nothing. The heat transfer, heat exchange. The overall process is what? Right, nicely. Now the overall, you must write the overall process correctly. Then the problem will automatically move on and to the destination of right answer. So overall process is what? Right, as it is given to you. So 50 grams of aluminum means 1.85 aluminum. Phase I don't know, so I don't know, keep it secret. What is this? What temperature? T, sir. T is the temperature. Plus, what is this? 5.55 water. This is liquid though. This is water means liquid. Then what is the temperature? 298. If I write 298 K or 298, it goes to where? Goes to what? Tell me. They are at the same temperature. They are at the same temperature. So 1.85. What they'll do? What they'll do to the final temperature? Heat will be transferred and they will attain the same temperature. What? 1.85 aluminum plus 5.5 H2O liquid. What temperature? They together at the same temperature T prime. Constant pressure. Constant pressure adiabatic. And quality 1. Now tell me what is the delta H1 again? Start. Now delta H1 is what? Tell me like before. Delta H1 is, since adiabatic constant pressure is Q, is 0. Macha. Delta H1 is 0, okay? Then what is this? Very good. This is 0 adiabatically contained. This is written adiabatically. Okay, very good. So this is 0. Now breakup. Will you give a breakup here? You can give a breakup. Let us do the breakup. Okay, breakup is what? Breakup for 1 overall. Is what quickly? 1 point. There is no chemical reaction. No chemical reaction. Right. Note there is no chemical reaction here. Note there is no chemical reaction between aluminum and H2O. I'm telling you, not only that, water liquid is not evaporating also, no phase transformation of water, etc., no complications, simple, between A and H2, given. So what is this? 1.85 easy, easiest aluminum, what temperature? T goes to 1.85 aluminum, T prime. This is actually sure. Okay. Acha, you do this yourself. Okay. Acha, let me write. Then another is what? 5.55. Since I have started, let us do this. H2 liquid 298 goes to 5.55 H2 liquid T prime. Same temperatures. Breakup. There is no chemical reaction. This is a very simple breakup. Okay. This is no. In fact, you may not do this. You can directly or this to this, this to this. Easy. So what is this? Breakup say A, B. So what is the delta H? A? Delta H is, tell me, 1.85 N moles Cp aluminum dt integration from T to T prime. Happy? What is the Cp aluminum is given to you? Perhaps Cp aluminum is given, I have written there somewhere. 16.3. This is 16.3. How much you are getting? If you are getting this, I have got this. 13, you do this. 16.3 and 1.85 is 30.15. You can write that. And what is the final temperature? T prime minus. You all set. Second, delta HB. Do this again. This is The pure heating means CVDT. CVDT or CVDT. Internal energy CVDT. DH. This is what? Tell me, what is how many moles? 5.55. Good boy. Is it phase transformation? Is it phase transformation? Now then it will be liquid to different phase, solid maybe, or vapor. No, liquid remains, only heating. So this is CpH2, CpH2 liquid, integration from hot temperature 298 to that same final of T prime and dt. How much it is? CpH2 is given to you as 75.44. 75.44. So you just see, this is the T here. Sorry, this is the T, 75.44. How much it is coming as? I'll check this. Before this, let me remove this. No, there is no chemical reaction. Breakup is already over. Overall process is over. So I don't have to. Very good. Still, what is that value? Tell me. Tell. What is the answer? Someone told me.
419.2.
Exactly. I got this. You can check this for 418.69 T prime minus 298. Easiest. Okay. Then next is what? You double star, and that's it. Now we remove the problem. There is no need to keep the problem, retain the problem anymore. So what is this? Then what you say overall is now delta H1 the overall is delta H the breakup A plus delta HB, because you clearly see this is AB delta HA plus delta HB. This is what you have already seen 0. Hence you can write this. Hence 0 is 30.15. You do yourself now. T prime minus T plus 418.69 times T prime minus 298. Then you get a relation between T prime and T, which you will be, it is up to you. Let me check. Okay, very good. Hence T prime is, this gives to T prime is 0.0672 T. You do yourself the remaining part and no difficulty. Answer. Happy though? How many minutes? Time. Past. We didn't mention. So is teacher got it? Yes, so who's that is? Possibly subto. Quickly, second problem is so easy that next day I will consider 3 is withdrawn. Problem 4, 5, 6 means tomorrow. Day after tomorrow, I'm very sorry. Day after tomorrow. So can I remove this? Remove this. So, good boy. Quickly, this is so easy. Problem 2 is the easiest. What it says? Oh, write that problem quickly. The heat of, this quickly, the heat of combustion. The heat of combustion. This is Basuruddin coming, then I'll stop. Anyway, it will take 3 minutes in any case. This is the easiest. No. The heat of combustion, just let me quickly, the heat of combustion, I should write the problem, okay? The heat of combustion of tungsten carbide, This is a very hard material, wear resistant material. Tungsten carbide metallurgical importance at 298 K is minus 11985 kilojoule per mole. Why minus? Please tell me why minus, why not plus? Fuel, this is fuel. Combustion means fuel is oxidizing always. See, it is actually, because that is the job of the fuel, to give heat. So fuel combustion is an exothermic process. So let us stop this. I'll take up this problem. It's already written. Oh, I'm not completed. I'll start tomorrow. Okay. Okay. With this parts. Okay. We have actually concluded today's class. Let us call it a day.